In this video, I'm just going to go over the theory around the normal distribution, and then in the next video, I'll do some examples to highlight some of these principles. So what is a normal distribution? Okay, you might have heard of a bell curve or a bell-shaped curve. So a normal distribution is a bell-shaped frequency distribution curve where the mean, median, and the mode are equal. Okay, in fact, here's an example of a bell curve or a normal distribution. There's the mean. The mean's in the center. So the median would also be in the center, and so would the mode. Okay, so that would be the center line there. Half of the scores would be above the mean, and the other half are below the mean. Okay, something else to note, it's a smooth curve as well. Okay, no jagged edges. And these symbols here, so this symbol here is the symbol for the population mean. Sometimes we use X bar. I'll talk about that later. And this symbol here, sigma, is a standard deviation. Okay, so if we start at the mean, and from the mean we go one standard deviation above the mean, so you might have heard that as well in the past, where we go, plus or minus one standard deviation, or the mean plus two standard deviations. So if we go up one standard deviation, 34% of the scores will lie in this region here. Between negative one standard deviation and positive one standard deviation around the mean, we have 68% of the scores. Okay. If we go from minus two standard deviations to positive two standard deviations around the mean, we have 95% of the scores contained in that. So just a quick example, let's say for a maths exam, okay, that was done by thousands of students, maybe across the state, and the mean happened to be 80% and the standard deviation was 5%. So that means then that 68% of students scored between 75 and 85%. Okay, and I guess it's a general rule that holds true for a lot of things. What about negative 3 standard deviations, positive 3 standard deviations? That contains 99.7% of all the scores. Generally, it's around that percentage anyway. So it is rounded, but it's around 99.7%. And 100% of the scores is then if you go beyond the negative 3, positive 3 standard deviations, that's the remainder, 0.15% on either side. So that's the tail part there. Okay, this is called the empirical rule for a normal curve, and at least for standard 2 mathematics, part of this is in fact given to you obviously in the reference sheet, but it doesn't have all the percentages listed there. It's only got the percentages in blue here. So as you go further and further away from the mean, these percentages are given. Okay, so you would need to work out sort of each of these regions yourself. So just having a look at just a couple other points. Many natural phenomena such as height, blood pressure, pulse rate, skull width, for example, follow a normal distribution. In other words, as long as the sample is large enough, we're normally talking hundreds, maybe thousands of scores, maybe more. But generally speaking, as long as the sample is large enough, you're going to find that, generally speaking, 68% of all the scores are going to lie between plus or minus one standard deviation. So as an example, a large number of people are randomly surveyed for their height. The mean was found to be 170 centimeters. Okay, so I'll just put a little mu there for the mean, with a standard deviation of 5 centimeters. So there's our sigma. So assuming the heights are normally distributed, which generally they will be, this means that 68% of those surveyed had a height between 165 centimeters and 175 centimeters. So that's the mean plus or minus one standard deviation. The mean being 170 centimeters plus or minus one standard deviation. A standard deviation is worth 5 here, plus or minus 5 centimeters. So that gives us then our range of scores between 165 centimeters and 175 centimeters. If we go back to the diagram of the normal distribution, so this would be the 68% here. It's just this central region of the bell curve. Okay, and as we go further and further out, the area under the curve gets lower and lower each time, which means that, for example, going back to this heights example, Okay, if we go out 3 standard deviations, okay, what's 3 standard deviations? 3 standard deviations would be 15. Okay, so that would be 185 centimeters. So 3 standard deviations, where would that be? Okay, 3 standard deviations would be here. Very, very small or a very low number of scores would lie in this region there. Okay, so that's pretty much the normal distribution. Okay, I mean there's other aspects, of course, but thought I'd just keep it just keep it simple and keep it brief. And I think you'll see a lot more with the examples, and as well doing your own examples as well. You'll understand this a lot better. Just one other point to note on symbols, okay, and notation. These 2 symbols can be used for the mean. Okay, so if we're talking about the mean of a population, we use this symbol here, mu. Okay, so that's spelled like that, mu, mu. Or we use X bar. We've seen this one probably more often. That's the sample mean. So from a population, if you're just drawing a sample of, I don't know, 30 or 40, or just a sample of the population, we use this notation here for the mean. Okay. For standard deviation, if we're talking about the standard deviation of an entire population, it could be the entire population of the school, could be the population of a country, population of a state. As long as it's the entire group, we use this symbol here, which is a lowercase sigma, Greek letter sigma. If it's the standard deviation of a sample, so let's say, for example, the population of a school, we might be surveying 1 class, we would use a lowercase s. Either way, I think it's good for you to be able to see that if you see either of these 2, it refers to the standard deviation, but one refers to population, the other one refers to a sample. Okay. In the next video, I'm going to go through a couple of examples with you.